So we'll make a start. So just very briefly from myself. So I'm Mark Walker. I'm here kind of nominally representing Environmental Biotechnology Network, and I lead within that network. I lead the anaerobic digestion working group. So we got a great webinar lined up, great speakers, and our chair from ADBA. I guess just if I was to say anything, I would say to emphasize the great work of ADBA in promoting the AD industry in the UK, and obviously all the work and all the things that they do. But also the Task 37 is also an amazing institution, if that's what we can call it. Put on lots of amazing events and nice research into promoting the field of anaerobic digestion. I went to a very nice seminar on residual methane emissions last year with them. So yeah, if you don't know about Task 37, I hope today will be a nice introduction to that, and that you will engage with that in the future.
And that means
just to repeat myself earlier, we are hearing some speakers. Someone's got their microphone on, so please do mute yourself unless you are one of the speakers or chair. Thank you very much. Okay, so without further ado, we'll make a start. So I'll just introduce our chair for today, who is Andrew Brown from ADBA. So just a brief introduction. So Andrew is a recent addition to the ADBA team. He has a process engineering background and 5 years of experience in the AD industry itself. So he's been supporting investors and operators in all aspects of practical global AD developments. Andrew's focus has been on technical due diligence and AD plant design for investors, and he's been helping secure funding for new builds, plant upgrades for sites around the globe. Now, Andrew is supporting a range of initiatives at ADBA and at the sister company, WBA, to accelerate global rollout of sustainable and efficient AD operations. So without further ado, I'll hand over to you, Andrew, if you could start the webinar proper.
Yes, thank you very much, Mark. Excellent intro, much appreciated. And yeah, thank you very much, all of our attendees, for joining this afternoon. Yeah, we're very excited to host our webinar today. We're going to be looking at a recent study highlighting the application of anaerobic digestion and the food and beverage sector. We're going to be led by presentations from our experts here at Task 37. We've got Dr. Jan Liebetrau joining us and presenting, and we've got Dr. Bernhard Drosg also joining. And yeah, must highlight, this is a real crucial area in the whole industry around the globe, the application of AD in food and beverage. Just past couple of weeks here at ADBA, we've had a lot of contacts from the UK industry and global, talking about things like food waste coming in from households and local government schemes, things like source segregated food waste from local houses coming into AD plants. And we're quickly finding that there's quite a lack of infrastructure in a lot of cases, not enough biogas plants to deal with food waste and beverage waste that used to go to landfill or be discharged, say, that's now needing a place to be processed sustainably and efficiently, as we say. So yeah, I think this is a huge area for growth. I think we very much need AD developments. We need AD and biogas to step up to deal with these wastes that are coming our way, or byproducts in a lot of cases. And yeah, very excited to chair today and to lead presentations from Dr. Jan and Dr. Bernhard and the rest of the team at Task 37. So yeah, thank you very much, team at Task 37, for presenting to us today. Yeah, without further ado, I'll hand over to yourselves. If we could please take questions at the end of each presentation, please try not to interrupt our speakers. We'll be very happy to answer questions at the end. And please send any messages into the chat and we'll pick them up as we go along and at the end of the session. So yeah, if everyone could please be on mute, and we'll look forward to our presentations. So yeah, okay to crack on first then?
Yeah, hello everybody. I just pressed the button present in Teams. Can you see the presentation?
Yes, that's
Okay.
come up. Thank you.
And then I also assume you can hear me, otherwise you would never responded. So yeah, my name is Jan Liebetrau, and I'm also very happy to be able to present here. Just a couple of words to my person. I'm a civil engineer from education, and I did a PhD on process control on anaerobic digestion. I worked almost 2 years in Canada in a project where we tried to establish a biogas plant at a feedlot, came back to Germany, worked at the German Biogas Research Center in Leipzig, and I left that in 2020 and went to southwest of Germany, and I'm now there working at the planning office. We are planning biogas plants, mainly at the moment plants which are treating municipal solid waste, and we're also dealing with landfill gas applications and doing a lot of feasibility studies for the development of these in Germany. But I'm here now to introduce IEA Bioenergy Task 37 to you. I'm doing this as a task leader, and very interesting maybe for you is that this is my last day here as a task leader. So the next task leader for the triennial, which is active right now already, is Bernhard Drosg. So the second presentation will be given by the new task leader of Task 37. And still, I'm very glad here to introduce to you what we have done in the last 3 years, and also what we are planning, or what Task 37 is planning to do in the next 3 years. IEA Bioenergy is a so-called technical collaboration program, and these phases, or this emphasizes on the deployment of environmental, socially acceptable and cost competitive bioenergy systems. And this collaboration program is there to collect and make information available which allow a analysis and also an evaluation of these technologies. We are independent and it's a non-profit organization, and it's focused on delivering clear and verified information on bioenergy to all stakeholders. So of course, policymakers are our focus, but also plant operators and investors. So whoever is interested in information on bioenergy. IEA Bioenergy is not IEA. This is sometimes mixed up a little bit. It's a technical collaboration program under the auspices of IEA. So we are a little subunit of the big IEA, the International Energy Agency. And international technical collaboration programs function a little bit as working tasks under the auspices of IEA. IEA Bioenergy has 26 members. These are 15 European countries, plus the European Community, US, Canada, Brazil, China, India, Japan, Korea, Australia, New Zealand, as you can see there. These are the members on the map. So we cover quite the globe, I'd say. And within IEA Bioenergy, the work is again divided into working groups, and they deal with different aspects of bioenergy. So it's system perspective, it's the energy, product markets, conversion resources. This is how the secretary of IEA Bioenergy has tried to put that in a frame. Task 37 is called Energy from Biogas, and we are a more technical task. So we are dealing with aspects of biogas production and utilization with a clear technical focus. These are the members of IEA Bioenergy Task 37. So out of this 26, 15 countries have decided to work within task 37 in the last triennium. So in the next triennium, it's not 100% clear, but most of them will stay, and most of them have been active over many years in the task 37. We kind of formulate key challenges or key views on the biogas sector. And so these are the ones we have defined for the last triennium. So first of all, biogas technology, it's not only energy. We are not talking only about energy provision here. That it has been maybe the case in 10, 15 years ago, but now we have much more aspects to deal with and also much more benefits from biogas production or biogas technology. We need also byproduct valorization in the sector. This is a very important point. We talked recently a lot about CO2 utilization, digestate utilization, the most obvious ones, but there is also as climate protection, as water body protection, as air pollution protection. These are all aspects which are coming with biogas technologies. There's also a topic which is in this triennium now very or will be one of the main topics here is the biotechnology process performance, so the microbial mixed cultures in the biogas process. So we will focus on that. The economics, of course, that's a lot of discussion. Energy from biogas in Germany, for instance, is to be said to be too expensive. And the cost is often the main barrier. So we want to compare cost structures and see where there's optimization potential in the next triennium. And of course, we have a different state of biogas deployment in member countries. And this is something where this technical collaboration program can really provide an extra benefit to the readers or to everybody who is interested in our output, because we can compare the situation in different countries and provide also learnings from certain developments, experience from certain developments, and we can also provide information what is functioning and what is not functioning. This has been the major topics of the work program of the triennium where I was task leader, and which is just finished at the end of last year. We focused on co-benefits of anaerobic digestion. There will be a report which we will soon publish on that topic. It's very difficult to quantify that in everything except biogas and digestate. Or CO2. You can put masses and prices on that, but it's very difficult to put prices on water protection or other aspects which are co-benefits also of anaerobic digestion. We have looked on the situation of manual utilization in several countries. There has been a report out in 21, and we have kind of included new countries into this version here, and also came up with some ideas on barriers and how to get manure more into utilization in biogas plants. This report will also be published soon. Decarbonization of food and beverage industry. We have a couple of reports on that. One will be presented here after that presentation from Bernhard. And the second one we have from Ireland, where has been more looked into the evaluation of sectoral impact on the use of biogas in that sector. Energy and transport fuels from renewable gases. That was a report published at the beginning of last year. This is mainly looking on power to gas concepts. How to reduce methane slip at biogas system in landfills is a report dealing on different technologies, treating lean gas. Lean gas means methane gases with low methane concentration, how they can be treated, how the methane can be oxidized here. This is needed, for instance, in the biogas application to treat off gas from the upgrading process. And also in landfill applications, old landfills have low methane concentration. So that is a report which also will be published soon. So it's ready and just sitting there to be published. We have several case stories. Case stories are an instrument for us to present successful technology or organizational concepts. We have a case story, for instance, on a biomass trading platform. We have a case story on a power to gas plant. We have a case story just recently put out on a CO2 separation and preparation liquefaction plant from Switzerland. So these are technical examples. Country report summary is a update on the development in several countries. Usually not all of the countries are involved there, but we have 6 and 7 countries in this report, which has been published last year. And last but not least, we have a monthly newsletter, which I only can recommend. It's done by Arthur Wellinger, who was also a task leader of Task 37 in the past. And he, very diligent, is looking for news around the globe on biogas development and is sending out this newsletter every month. So if you are interested to subscribe to that, you find the link on our website. This is also all of the products are freely available. They are available in English, or what Germans and French and Swiss people think English is. So we do our best here, but I think for native speakers, sometimes this might sound a little bit difficult, but this is the way as it is. There are some examples from publications from mainly here 21. I already discussed a little bit what the content of those is, and these are the ones which the biogas systems in industry, the analysis of the sectoral usage, sustainability, logistics, and technology development is already out, so this can be downloaded from our website. The other two here, which I already named, they are soon available. I think we will put them online next week. And now, last but not least, this was all what we have done in the past, and this is the program for the future here. So we will keep on going on that assessment of co-benefits because we learned that it's quite difficult, and we also have limited resources in the task, of course. But we would like to continue to work on that because it's a very important topic to get an overall evaluation of the technology and not only focusing on energy here. We would like to look at the utilization of digestate as a fertilizer. There's increasing discussions, of course, on certain substances, materials which are beneficial for the land, of course, but also we have a lot of discussions on substances which are not so beneficial and they are discussed to be dangerous. So this is a very important point because the digestate as a fertilizer, I think, is one of the crucial aspects of AD applications. Microbial cultures, I already mentioned. The economics we discussed, we want to look into that. We have the country report summary. We will do that again. This is once in the triennium, in this 3-year working span, we will publish one of those reports. We will keep on going on the showcases for successful biogas applications, and last but not least, the task plans to speed up a little bit on also webinars and workshops. So this should help also to spread the word and also bring out the message which is hidden in our reports. The reports are quite long, and it's from our perspective more and more difficult to get people to read this. So that's why we also would like to improve a little bit that dissemination activity by accompanying these reports with webinars and workshops. These are The ways how you can find us, we also have a LinkedIn account where we would like to work together with the big IEA Bioenergy account and also transport the information and the reports, of course. But other than that, you can look at our website, of course, and also subscribe to the newsletter done by Otto Wellinger. That's from my side. If you have questions, feel free to ask. And I'm looking forward to the presentation from Bernhard, who will follow up this presentation.
Two quick burning questions whilst it's relevant before we go on to Dr. Bernhard's. Is there anybody in the audience that would like to chip in? We do have one in the chat from Louise Byfield, where on the benefits of AD, sometimes you only appreciate something when it's gone. Yeah, absolutely. So are there any case studies of the impact of an AD plant closing?
I'm not aware of that. We have that situation in Germany. They are looking at the whole sector because we have now for many plants the phase of a 20-year support ending. So not all of them will continue to produce biogas due to several reasons. It's of course the support scheme, but it's also an age thing because people who have decided 20 years ago to build a biogas plant, they might now be in their 60s. And if the little farmyard is changing and the family will not take over, then of course this is also a reason why this ends. We have a lot of discussions in Germany when we have no sun and no wind, then prices ramp up quite a bit on the electricity market. But biogas doesn't seem to get the attention there, which it actually deserves. However, quite surprisingly, you might know that our parliament decided to end the government of the previous government. And just prior to the new elections, they passed a new biomass support scheme, where a lot of the things which the Biogas Association in Germany claimed were actually taken care of. So that was quite a big step. So they were quite happy about that biogas got a new chance there. But still, we will see a substantial number of plants going out there. But I haven't seen a study on looking really on the impacts of that.
Perhaps it's coming soon, as you say, with the time periods. In the UK, we see government subsidies lasting 15 or 20 years. So plants built in 2005 are running out of that subsidy now, and they're not sure what their financial support will be going forwards. So yeah, that's something we'll be paying attention to now going forwards, really. Great. I'm conscious of time. We're now approaching the 30-minute mark. Thank you very much for your questions in the chat. We'll try and get time to come to them at the end. Shall we move on to our next presentation? Dr. Bernhard, please lead the way.
Thank you. So you should now be able to see my slide. True? Good.
Yes.
Yeah, welcome to my presentation. My name is Bernhard Drosg, and I'm head of a research area in the Austrian Bioenergy Competence Center. It's called BEST, and senior scientist at BOKU University, which is the Agricultural University of Vienna. I've been 17 years in the biogas field, biogas research, consulting, And actually, I've been 15 years now in IEA Bioenergy Technology Collaboration Program. So yeah, I'm very happy to represent today mainly a publication which we have been doing, and I would like to also highlight from my colleague Wolfgang Gabauer contribution to this report, also from BOKU University. So titled for today is Example of Biogas Installations of the Food and Beverage Industry. So I will give one slide on biogas background, then talk a little about the residues we have in the food and beverage industry. And the main focus will be examples of realized biogas installations at food processing or beverage processing units, and then a short conclusion on this. Yeah, maybe let's start with a sentence. So the food and beverage industry is one of the industries which have its own production process, residues and byproducts which can be used for biogas production. So this is a very special case compared to other industries. And yeah, don't want to go too much into detail on the biogas process, so I just copied here a figure from the report which was provided by the World Biogas Association. So we have a biogas plant which produces biogas which can be used for heat, electricity or biomethane. We can then reuse digestate for crop production, and we can also use CO2. And in the end, we will have again from crop production organic wastes, in my case from food and beverage production, which then enters the biogas process. So just a very short introduction. Yeah, I have a short sneak preview for you. So this is the report which is actually to be published probably in March. It's called Implementation of Anaerobic Digestion Facilities in the Food and Beverage Industry. Here you can see the citation. So there are also other authors apart from Wolfgang and me which have contributed. And yeah, you will find there a guide, especially for the food and beverage industry, how to consider biogas as an option. And then they're given examples of different industries. So what is important when you think about biogas and the food and beverage industry? So we have here residues, we have waste, and we have wastewaters, which contain organic matter. And there are different utilization scenarios. So you can utilize it for example, reuse. So the resource can be reused in the process, or you have animal feed as a byproduct. And then you go to a final treatment or disposal, which can be aerobic treatment plant, combustion, or composting. It's possible to combine it. So you have here also the option to first take out from the residue some secondary feedstock, put the rest into a biogas plant. And you can directly use, for example, a high-strength wastewater in a biogas plant. Then, of course, if you have a low-strength wastewater, it will be probably directly put to the sewer system or to a river, to an anaerobic treatment. So you can see it's a bit different approaches, but for example, here in these cases, we can utilize a biogas plant in the process, and that's what I'm going to talk about today. So the main part now are the different examples. So we have a Grana company, which is a sugar producing company. They produce sugar from sugar beet. So they're decarbonizing this sugar production. So there's a plant in Hungary located in Kaposvár where they process about 7,000 tons of sugar beets per year. It's a campaign process, so it starts in about September to January, February. So about half time of the year it's in operation. And they started in 2007, built to about 13,000 cubic meter continuously steered tank reactors. And they expanded the process in 2012. And in 2015, they put up a biomethane upgrading unit. So to give you some numbers, it's actually quite a large plant producing about 180,000 cubic meter a day. You have thermal energy, which can replace about 80% of the heat demand. So sugar production is quite heat demanding. And so it's about 10 million fossil cubic meters. Here you see a picture of the plant there with some of the fermenters. There's also the meat industry where we have specific residues and wastes. Here in this case, I first want to show an example from Austria. Here we have the company Großfurtner. They're located in St. Martin in Austria with about 550,000 pigs per year and 50,000 cows per year. They inaugurated their plant 2003. And this is very special because it's a mono fermentation of slaughterhouse waste. So often slaughterhouse waste is used in co-digestion, which means you mix it with a low nitrogen feedstock. And this plant actually has up to 7,000 milligrams of ammonia nitrogen per liter. So it's quite a challenging process. They're also operating typical CSTR reactors, so they have two 1,000 cubic meter and one 600 cubic meter. Here you see it, they're submerged into the soil because this was actually in this province when they got the permit way they built it. Biogas production about 5,000 cubic meter per day and about 500 kilowatt of electrical energy. Just one more slide also for this process. So you can find here a publication on this. Here you see the different fermenters and the final storage tank. And here they have a pasteurization unit. And in this case, they also use geothermal heat together with the biogas plant. And the main feedstocks are blood, fat scrubber and hind gut from animal slaughtering processes. An interesting example also from meat processing is Free Mesa Cooperative. I'm very thankful to the colleagues from Brazil from the task who provided this information. So it's in the state of Paraná. And they have about 2 million pigs, which are slaughtered per year. And they started 2011 with anaerobic lagoon system, which is actually covered lagoons with not so much steering and heating. And then they changed 2018 to a CSTR technology. So you can see here the two 3,700 cubic meters CSTR reactors, and they have 860 cubic meter mixing tank. From the biogas productions, about 8,700 cubic meters per day, and thermal energy, it's about 13 million kilowatt hours per year. And actually, they use it in the process and replace fossil-based gas, which they've been used previously. Interesting areas also distillery industry. So we have anaerobic utilization of the stillage, which is the leftover after, for example, cognac production. Company here is a French company, Revico, and they're located in Saint-Laurent-de-Cognac in France. They accumulate about 300,000 tons of stillage as a byproduct in cognac production. And what is very interesting, they already started in the 1970s with the biogas project. Currently have 4 CSTR reactors with about 4,400 cubic meters each, and produce about 13,000 cubic meters per day and 1.6 megawatt of electrical energy. Yeah, here you can see a picture of the plant located in the cognac production area. To next beverage, it's a beer production. So of course, a lot of consumption worldwide. So also interesting process to multiply. It's utilizing the brewer's spent grain. So often you find in beer production biogas plants which utilize the wastewater, but in this case, it's about the solid residues. It's here you can see in the picture, it's called Gösser, but it's part of the Brauunion Österreich, and it's located in Styria in the country of Leoben, and produce about 100 million liter beer per year. In 2015, the biogas plant was started up. It has 2 CSTR reactors, one about 2,500 and one 3,700 cubic meters, and also pre-acidification reactor where the brewer spent grains are pre-treated. The production is about 6,900 cubic meters per day and 450 kilowatts of electric energy. So the last example I will show you today is the decarbonization of potato processing industry. Here we have biogas production from potato processing waste. It's located in Austria, in Frastanz. It processes about 75 tons of potatoes per year. The plant was built or was started 2017, roughly 4,000 cubic meter continuously steered tank reactor. In this case, they produce biomethane, so about 8,000 cubic meter per day of biogas or 4,100 cubic meter of biomethane. Conclusions, my last slide for today. So my intention was really today to show you the broad range of applications in the industry. It's sometimes not that easy to obtain this information, so I think it's a valuable contribution, and also to give examples to other cases. We have in the food and beverage industry wastewater, waste and byproducts, and they can in many cases be interesting feedstocks for biogas plants. As already mentioned, a large variety of examples worldwide, and it's worth to mention that it's not always possible to buy, in these cases, a biogas technology off the shelf. So the systems are integrated in the industrial processes with the byproducts utilization, and also with agricultural value chains. And what is also something to highlight is that depending on the boundary conditions, of course, the industry already does it, but just to mention it, normally you do high value utilization, so you reuse parts in the process to food, or you can have like animal feed, and then biogas is an option. So I just showed the technological possibilities, but of course, depending on the boundary conditions, may bring other utilization concept makes more sense. So thanks a lot for your attention, and I'm happy to answer your questions.
Thank you very much, Dr. Bernhard. That was excellent. I appreciate it. It is indeed difficult to get so many case studies and examples, and it's difficult to present them as clearly as you have. So thank you very much. Some very fascinating examples. I very quickly say for myself that the industry in the UK, and I'm sure around the world, needs this kind of rollout quite desperately. As I said, in the UK, what we have is local governments telling each individual households, all your food waste is to be collected, and it's no longer going to landfill, it's going to the biogas plants. And the biogas plants are saying, great, we'll take your household food waste. But for the food and drinks and beverage manufacturers, their waste is not high quality. It cannot compete with food waste from households. The fat content, the carbohydrates versus the effluent, mostly water from some drinks. And so we see that the food and drink beverage manufacturers are going to have to install biogas on their site, as per all of your examples. We're going to need some CSTRs on site. They're going to need CHPs or biomethane installed. And in that case, we're very much going to need more. So thank you for that. Let's keep on the work. We've got a few questions come in. It's excellent time, and we've got 20 minutes, so we'll open the floor to questions. I'm going back in the chat. The first one, or the oldest one that we have not yet answered, is cost the major challenge in setting up an AD plant to recover food and agricultural waste? Is it cost restrictions or something else?
I don't know, Jan, do you want to answer to this general question, or shall I answer from my side?
I have a very personal opinion on that, and we are talking here about renewable energy, and when we come into the cost discussion, it's always compared to fossil energy. They said, oh, this is too expensive. But this is comparing apples and oranges, because the one energy carrier comes with a lot of CO2 emissions, which we want to avoid, and the other one doesn't. And that's why I struggle always to answer this question. Of course, if you compare it to current standard of fossil energy supply, then it's more costly to set up a biogas plant and utilize the. It's not in all cases, I should say. There's still cases out there that's even cost efficient to do anaerobic digestion on waste streams, but still very often it's cheaper to buy fossil energy than using the waste. And that's, I think, the problem here is that the CO2 doesn't have the price which it should have. And then this cost discussion is a different one. And this is also what I wrote in the chat, that this is the major challenge, I think, of the future, that we need a framework where these technologies are set in a context where renewable energy can actually be competitive to fossil energy, and otherwise it won't work. But you all know the political situation in Europe and in the US at the moment, and war and whatever we have, and it's very difficult to have these discussions at the moment. Nobody wants increasing CO2 prices at the moment. At least in Germany, they don't want that. But as an example, we have in Germany now an increase on the CO2 price for industry up to 55 euro a ton CO2. And we have a quota in the transportation sector where the price was around 250 euro a ton to substitute gasoline and diesel by biodiesel, by ethanol, and by biomethane. That was the cost the industry had to substitute fossil fuels. And that is the difference, I think, which we need politicians to be aware, and where they should see that there's a benefit to a renewable energy carrier which needs to be compensated in some way. And then we are cost competitive, and then the cost is not the point anymore.
Thank you very much. Yeah.
Maybe I can mention just a little bit from my presentation. So there are various examples which exist, of course, due to subsidies. So it's either renewable electricity or biomethane. However, I'm not 100% sure, but I would think like the plant, like the Brazilian ones, that they are also without subsidies working, but generally majority, and also slaughterhouse waste, I would consider, depends on the situation, how much you have to normally pay for getting rid of the waste. So yeah, of course, several of the plants receive subsidies. So of course, then they're working economically sound. But there are examples which would also work without subsidies. It's my opinion.
Yeah, I would like to add that very often the industry has to pay a certain fee on the degree of pollution of their wastewater or their effluent. And then, of course, anaerobic digestion is very cheap technology to reduce the COD content of the effluent. And then this is, of course, very quickly cost efficient to treat the off-stream or the effluent from a facility by means of anaerobic digestion to reduce the costs on disposal of the wastewater.
Excellent. Thank you very much. Other than cost, perhaps we would say it's planning delays, and perhaps kind of local agreement to get biogas plants up and running. I would say of the many developers, investors, and operators I've worked with, cost is number one, but you can get over it with subsidy. But when you come to wanting to actually build your plant, the delays and the challenges with the local opposition are very, very significant. We're working with major oil and gas companies right now, Shell, BP, Chevron, etc. And actually, these guys have the money. These guys they're building big enough plants to make it cost competitive, subsidy or not. But the challenge for the construction is on local opposition, right or wrong. Okay, great. I'm just posting. Let's see. The next question we had was from David Baxter in the chat. It's unfortunate that there's so much talk of decarbonization with respect to climate change. Is there an IEA approach and even an alternative term to decarbonization? We have Yadira who suggested defossilization in terms of terminology. What's the thoughts?
Yeah, like we in our institution, we tend to use defossilization. However, like I held this presentation first in industry context with industries which are quite far away, so often people understand easier, but David is actually 100% right. Of course, if we use renewable carbon, we don't defossilize, we don't decarbonize because carbon is there, but we remove the aspect that it comes from fossil based resources.
Yes, indeed. In the UK, we're seeing huge focus on electrification from other renewables, wind and solar. And yeah, when it comes to decarbonisation, I wonder sometimes if that leaves biogas out of the mix because there's such a focus on electricity in non-carbon sources, and whereas biogas can be decarbonising. Yeah. Okay, on to the next question we've got from, sorry, Dr. Jan.
And we need carbon. We need this decarbonization might help in some of the energy sectors, but in the material sector, we need a lot of carbon. And if this is not coming from a fossil source, it needs to come from somewhere. We have that development already in the biogas and the biomass sector, but with CO2. But other than that, we need other carbon sources for other sectors as well if we want to be there also on a renewable basis. So decarbonization has limits.
Yeah, exactly. Very good. Okay, the next question is from Louise Byfield. What research areas are you particularly excited to see transition from academia to industry? For example, bioelectrochemistry or biomethanization, platform chemistry, product extraction, or anything else? Biomethanization is one I'm looking at. Well, how about yourselves?
Like we're very much based as a research center on also more fundamental research. So together with a professor in Turin, Professor Werner Fuchs, we have topics like electrofermentation, yeah, to combine electricity and fermentation processes. Of course, biomethanation is an interesting topic, and as already was mentioned, we want to go also into the microbiome to a bit more use the molecular biological methods which have been advanced in the recent 10 years to understand more of the mixed culture. So these are important topics we do in our group with regard to research.
Okay, understood. I would encourage anybody looking at biomethanization to, of course, look up Nature Energy. They had interesting projects of putting hydrogen in situ, injecting into the anaerobic digester to increase methane concentrations. I find that very fascinating. If we can get our biogas CH4 methane percentage from 60 to 90, as an engineer, I see huge potential there.
Yeah. We have to discuss also power to gas a little bit in our publications. And of course, this is what I also wrote in the chat. When it comes to hydrogen, I think if we talk about renewable gases, not only renewable electricity, if we talk about renewable gases, I think where methane is cost competitive with hydrogen at the moment, for sure. We are cheaper actually than renewable hydrogen. So if you put hydrogen into a anaerobic digester, you increase the cost, I would say. You improve the quality of the gas, but adding to the cost of the hydrogen, you need to make sure that the hydrogen it's not very well soluble in the liquid, so you need to make sure that you have a good distribution in there. This is effort, and it adds to the cost. This is what I want to say. But in average, it will be cheaper still than hydrogen if you mix these two. So it is, to me, and I agree with that, with you, Andrew, that it is really a chance to improve, to make also biogas plants to a sink for electricity in certain times, to take electricity out of the grid if there is excess electricity, and put the energy into the gas grid. And these are all, I think, very important services we need in the future. And this is one more aspect where biogas industry can contribute, actually.
Yeah, very good perspective. Yeah, I look at the cost front, and of course, hydrogen's expensive. But one thing I'm looking at and considering is, does it, if you've got 80% methane or 90% even, then perhaps you need less OPEX to run your facility for the cleaning process to get to 99%. Perhaps you need less CapEx because your units can be smaller. So whilst the hydrogen cost is more, the cost to upgrade the biogas from high methane to biomethane for the grid, perhaps you get some savings there. So that's one thing I'm looking at. Maybe we can chat later and see if that's been looked at before. Right, I'll stop talking myself. What else have we got? We've got another question. How can food wastewater with high oil content be effectively utilized in a biogas plant?
I cannot really respond to this because I have not really had issues on this, and so yeah, I'm not sure. I have not seen with the companies which we have what, for example, the slaughterhouse industry does. So they have a flotation unit where they kind of get the grease sludge out of the water and then put it into the biogas plant. So this is something, but yeah, I don't know if Jan has anything to say on this.
Well, just a general thing is what when we are looking at all these examples from Bernhard is very obvious that there's so many different wastewaters and materials, and the one has a very high salt content, the other one, ammonia was mentioned here, very high ammonia content, and many of them have very specific characteristics, and this is also something we highlighted in that report, that it really, at these applications, it makes a lot of sense to pay attention to the planning, to the feasibility phase, to really look into the characteristics of the substrates, to do maybe experiments on this very specific substrate to find solutions before you build a plant and find out that this is not working with the substrate you have there. And oil is one of the aspects here, but this is very, very specific. We have 10,000 plants in Germany, and 8,000 of them work with corn silage. And there, of course, we have experience. But with this one very particular oil, which you have in a processing process, food processing technology, then that's a different story. So this is something I highly recommend to look at these characteristics and to make sure that you have a process which is really working on this substrate.
Excellent. Yeah, it was a similar question right after, how do food waste biogas plants deal with long chain fatty acids, so oils in a lot of cases.
Yeah, long chain fatty acids is, to me, I don't know what you think of as C6, 7, 8 or something like that, or even longer than, because usually from the biological process of anaerobic digestion, you have an accumulation of long chain fatty acids if something goes wrong in the process. So that means you have some sort of an inhibition in the process if you have an accumulation of that. Of course, fat and grease and stuff like that is not really soluble, so you need certain technology, retention time, whatever, to make this accessible for the microorganisms. Once they have broken it down, I think it's to be digested if you have no inhibition there. And I'm not an expert in this long chain fatty acid thing, I should say. I know a little bit about ammonia, and I know there that retention time helps, of course. The less the system is stressed, the more it can stand inhibitory conditions, the more it can handle such more difficult process states. This is what I can say to that. But as I said, I'm not an expert in this long chain fatty acid, but there are publications on that. So I recall I've seen over the years some of them on long chain fatty acids in specifics.
Great. Yeah, no, I agree. Of course, operators on site always study something called the FOSTAC, which is effectively the ratio of volatile fatty acids to the buffer capacity, alkaline buffer capacity. So if your FOSTAC levels from a sample are spiking or dipping, then it means there is an imbalance, as you've said, Dr. Jan. So yeah, I think operators currently do look at this. It's part of a ongoing routine. But yes, when it comes to these longer chains, insolubility becomes a concern. Real. Okay. Yeah, just looking through for other questions. That's us pretty much on time, and I don't think there's any more burning questions other than from ourselves. Thank you very much, Mark and Sonia. Yep, thank you very much, Angela Bywater, for the link. I'll check that out. Yeah, and thank you very much, Yadira, on the work with extreme ammonia levels in AD 8 grams per liter. Yeah, that is interesting. But yeah, I do wonder with the side examples, and we talk about high ammonia content, if ammonia scrubbing is common amongst all sites. I think it is fascinating when you combine some ammonium scrubbing with sulfuric acid, create ammonium sulfate. Fantastic fertilizer. I've seen that on a few plants. Okay, we're bang on time. Well, there's questions coming in still. Would you like to answer more questions, or shall we call it that time?
Couple of questions I could handle, but that's I don't know.
I'm also flexible.
Yeah.
Okay. No, they're not so much questions, just comments coming in actually. So yeah, have a look at the chat. You've got a lot of thanks coming in. Likewise from myself. So yeah, pat on the back, and yeah, all audience members, please reach out. I think that's everybody dropping off now. Okay. Thank you very much.
Thank you.
Thanks a lot. Was a pleasure.
Thank you.
Yes, thank you to speakers
Likewise.
and chair.